I'm not sure why it's black. Oh my god. All right. So I want you guys to do the following example, okay? So we have an example here. And let's say that we want to find or we want to solve the following systems of equation. We have y equals x minus 2, and we have y equals negative 2x plus 7. Okay. So if we have a system of equations like this, to solve it means we got to find the point of intersection, which means we have to graph it essentially. All right, there's like 3 different ways to figure out a solution with the system of equations. We have algebraically, which involves solving by substitution and solving by elimination, and then we have graphically. So we're going to begin by solving this graphically, which is going to require us to find the following 2 things. For each line, we need to find the slope and the y-intercept. So for example, this first line, we have a slope of what? What's in front of the x? In front of the x. So you guys look at this, we have x. Do we see a number in front of x? No, but we can assume there's a 1, right? So we're saying this has a slope of 1, which is really 1 over 1, if we think about rise over run. And then the negative 2 is actually going to be our y-intercept, or starting point. We look at the second equation, we have negative 2x plus 7, so we have a slope of negative 2. The way it's going to work is the negative will actually apply to the 2, and then the denominator will be a positive. And so what this means is we're going down 2, but we're still going to the right 1. A lot of people tend to make the mistake where they think that the negative also applies to the bottom number, and then they're like going to the left. That's incorrect. We're always going to graph to the right. So this will be negative 2 down and 1 to the right. With, let's see here, b of 7. So starting value of 7. All right. So let's go ahead and graph these now that we know what they look like, or what they have, the elements that they have. I don't know why this is black, but I'm gonna have to like make here's your x and y axis right here. So with the grids on your paper, you're gonna make a graph, make an x and y axis, and of course each box will represent 1. You can't really see the grids from my end, but they're there. Oh, there it is. No, it's white. Good. That's what I wanted. Is black better or is white better? Black. Okay. We'll go black. Back to black. Okay, the one thing I do want is, how do I make it so that the let me try that. That's better. All right. So we're gonna graph x minus 2, and I'll do that one in like in green. So x minus 2, that means we're gonna start here at negative 2, which is down here, And then with the rise and run of 1, it's 1 over 1. Okay, so you guys have your points there. Yours might look a little different than mine because once again my axes are kind of weird since my like spacing is weird. But let's compare where they actually cross, and they should cross at the same point. I'm going to use red for the other part. Let's see, do we have like a softer red here? Then we start at 7, which is kind of like up here, and we're going down 2 over 1. Oops. Actually happens to be this point. It actually happened across here, and our solution will be 3 and 1. So this is our solution. This is the point of intersection essentially. All right, and this is what we're looking to get. So if you're doing this on your end, we're looking to find the following point of intersection, which is at the point 3 and 1. All right. Once again, that second function will start at 7, and you'll go down 2 and to the right 1, down 2 and to the right 1 again. Okay. All right. We're going to do one more example, and then we'll move on to substitution and elimination. So we're going to move on to the next page, if possible. Here is your second example. We have the following. Negative 5x plus y is equal to negative 9. And x plus 3y is equal to 21. All right, so here's the thing though. When we have this problem, you'll notice that we don't have it in slope-intercept form. You could consider this standard form for graphing. But like I said, it's not slope-intercept, so it's very difficult for us to see what exactly the slope is and what would be the y-intercept. So here's what you have to do. You have to solve for y first. All right. So let's talk about what that looks like. Is blue a good color, or should I change to a different color? Is that fine? Okay. So we have negative 5x plus y equals negative 9. We are looking to get this y by itself. So we have to move what's making y not be by itself, which in this case will be what variable? How do I get y by itself? What variable is in the way right now? Negative 5. And so how do I get rid of negative 5? Plus 5, the opposite would be plus 5. So plus 5x on both sides. Keep in mind you can't combine negative 9 and 5x because they're not like terms. But it will allow you to rewrite this as 5x minus 9. where we have 5 as your m value and -9 as your b value, right? So we're going to label these. M is equal to 5 and b is equal to -9. We are going to do the same for the second equation, x plus 3y equals 21. Let's do it over here. X plus 3y equals 21. To solve for y, we have to move the x first. So we're going to begin by subtracting x on both sides. Okay. What will the final step be to get y by itself? If I have 3y equals -x plus 21, the final step should be to do what? To divide by 3. Very good. So we're going to divide both sides by 3. Divide by 3. When you divide the right side by 3, you're dividing every single term by 3. So you're dividing the -x by 3, and you're dividing 21 by 3. Okay? And it's going to give you the following. Y equals -1/3 x. So or you could write it as -x/3. That's also fine. Plus 7. Let's go ahead and label the m, and we'll see if you guys actually can solve this one. So what is the value of m for this example? Is it 3? Is it -3? Go ahead. -1/3. So we're going down 1 and over 3. And then our b value is 7. Okay. All right. So we're going to go ahead and graph these now. So let's go ahead and I'll do it over here. Come up with a graph. Let's do white. Can you guys see the grids? The actual boxes now? I'm going to use green for the first function, which I'm going to write up here as well. Y equals 5x minus 9. We said that was one of the first ones. Minus 9. That's going to be down here. So I actually need more space. See, 1, 2, 3, 4, 5, 6, 7, 8. Oops, a little bit more. There it is. All right, so we have a point at -9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your first point at 9. Then you're going up 5 to the right 1. 1, 2, 3, 4, 5, and to the right 1. Right there. You guys can ignore this little point. 5 up from there. 1, 2, 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. Right? And let's go one more point. 1, 2, 3, 4, 5, 1. Now we can use yellow for the second function. I know you guys are doing it in in pencil or pen. So if you want to differentiate between them two, you can do one dotted, one solid, or like a dashed line, so you know which one's which. Just make sure you label them. This one's going to be, we said it was negative x over 3 plus 7. So we're starting at 7. 1, 2, 3, 4, 5, 6, 7. Down 1 over 3. Down 1 over 3. And I think that's all we have space for. Let's connect our points. And there should be a point of intersection. All right, so we're following this graph. Here in green we have 5x minus 9. Here in yellow we have negative x plus over 3 plus 7. When we graph it in red, we will see the point of intersection, which is the following. It's at 3, so it's going to be 3 comma 1, 2, 3, 4, 5, 6. So 3 comma 6. Right? That will be our solution. All right. How are you doing so far? We doing okay? Yep. All right. Next, we're going to talk about substitution, and then we'll get you guys your break, okay? So we're coming up on that first hour mark. Just hang tight. All right. So how does solving by substitution work? Let's take a look. So let's look at an example. Once again, you're going to have two variables. 2x plus 3y equals 9, and 5x minus y equals 14. So how do we even begin by solving by substitution? Well, the name substitution means you're going to take, well, first of all, you're going to solve for a variable, whether it's x or y, in either of these equations. You're going to pick a variable, solve for it, and then you're going to take that variable and replace it back in there. So let me list out the steps for you, and I'll talk about what some of these terms mean. So first of all, what you want to do is you want to identify the friendly variable. Let's call it the easy variable instead. Identify the easy variable. What does it mean to identify the easy variable? You're looking for the variable that you can solve for, which is going to require the least amount of work. Okay. So typically, you're looking for a variable where you only need one single step to solve for it. Can you guys figure out which one it's going to be? Is it going to be x? Is it going to be y? What do you think, Anthony? 5x minus y equals 14. Which of these two, 5x or y, will be my easy variable? Which one do you think? Is it going to be 5x? Am I going to be able to solve for x here with a single step? If I wanted to solve for x, I would need to move the y and then divide. That's 2 steps. Whereas if I want to solve for y, it's still 2 steps, but I'm not dividing by a bunch of numbers. I'm just getting rid of that 5x, and then it's the negative that I need to move. So in this case, our easy variable will be the following. It's going to be the y here in 5x minus y equals 14. So I'm just going to highlight that just so I know that I'm looking at an easy variable there. And then I'm going to go ahead and actually solve for it. Right, so you identify the easy variable and then you solve for it. Let's do that here on the side. To solve for a variable, you guys know that we are using SATMAP, right? We are working backwards, so we're going to add and subtract first and then divide. That's what I mean, okay? So we're going to first move the 5x to the other side. Negative y equals negative 5x plus 14. Finally, we divide by negative 1. We're dividing everything by negative 1. Such that y is equal to 5x minus 14. All right. You guys good with solving for y? Yes? Okay, cool. So what do we do next? So once you've identified the easy variable and that you've actually solved for it, this is where the substitution portion comes in. Your second step will be to substitute oh I was right. Substitute the equation into the other equation. So what do I mean when I say substitute the equation into the other equation? We know that y is equal to 5x minus 14. So we're going to take this equation, 5x minus 14, and we're going to substitute it back into the first one. It means anytime you see a y in the first equation, we're going to take the y and we're going to replace it with 5x minus 14. Right. The reason why we're doing this is when you have two variables, you can't solve for either one because there's too much unknown. You need it all in a single variable term. When we take 5x minus 14 and plug it in here, you're only dealing with x's now. And that we can solve for. So, like I said, we're going to take the 5x minus 14, we're going to plug it into 2x plus 3. I'll do that over here. We have 2x plus 3y equals 9. However, we're going to replace the y with the following equation, which is what we solved for, 5x minus 14. Okay. Once again, we're replacing the y with the equation 5x minus 14. We're going to set that equal to 9, right? That's what we had it originally set up. And you will have to solve this, all right? You will have to solve this. So how do we solve this? Let's talk about solving an equation like this. Well, it's going to require us to use order of operations. Now we're using PEMDAS going forwards, right? So first, deal with parentheses. 5x minus 14 is already simplified. We can't do anything with 5x minus 14, but we can actually move down the list. We don't have any exponents, so P and E are out of the way. M stands for multiplication. We can multiply, and we will multiply. We are going to distribute 3 to 5x and to negative 14. Two x plus 15x minus 42 equals 9. At this point, we combine like terms. 2x and 15x make 17x. 17x minus 42 equals 9. Go ahead and give me the next step. This one should be easy. What is the next step? 42. So move the 42. 17x equals 51. Final step. Let me hear the final step. To get x alone. What do we think? Go ahead, Jorge. Divide both sides by 17. And we find that x is equal to, it should be 3. X is equal to 3. How are we doing so far? Are we all good with this? Solving for x? Okay. So we have solved for one variable. Here's your final step is the following. Solve for remaining variable. Solve for the remaining variable. How are we going to do that? Substitute what you have. In this case, we have x. Let's take x and substitute it back into an equation so we can solve for y. All right? I'm going to do this over here. Let's take purple. I'm done purple. Or orange. Okay. So we have y equals 5x minus 14. And by the way, you can use any equation that you want. You don't have to stick with this one. I'm just using this one because I think it's going to be the easiest. All right. 5x minus 14, I'm going to replace this x with the value of x that we just solved for. So that's going to be y equals 5 times 3 minus 14. Well, 5 times 3 is 15. 15 minus 14 is going to equal 1. And we have solved for both variables. All right. So our solution is 3 and 1. I'm going to leave this work up here. I'm going to give you one example to work on with your team, and then we'll take our break. You're going to have about 6 minutes for this one. So, does anyone need anything from this question before I put up the next one? I want you guys to use the steps. Yes. Oh, it should be positive one. I'm sorry. Positive one. Whoops. There it is. Should be 3 and 1. All right, here is your second example then. And like I said, do this one and then take your break. So here it is. Example number 2. I want you guys to use the following: x plus 3y equals 0 and 2x plus 6y equals 5. You guys have 6 minutes. It starts now. If you have any questions, call me over. Once again, the first step is to pick a variable to cancel. So you can either pick x or you could pick y. I'm going to kind of deviate from the notes here. Which variable would you guys like to cancel first, x or y? Y. Okay, let's start with y then. If we want to cancel y, then we need for these two to be opposites of each other. All right. So 7 and 2 are obviously not opposites of each other, which means we have to find a common multiple so that we are able to cancel them out. What is a common multiple of 7 and 2? 14. Yes, excellent. So let me write that as your next step. Your next step is to find a common multiple, if applicable, which in this case it does apply. So the common multiple between 7 and 2 will be 14, which means we need to multiply 7 by something to get 14, and then we also have to multiply 2 by something to get not positive 14, but the inverse, negative 14, because the goal is to cancel these out. Okay, so what am I going to multiply the top by? How do I get 7 to equal 14? I multiply by what? By 2. So I'm going to multiply everything by 2. I'm going to place parentheses around the whole thing and then in a 2 in front. That's telling me that I'm multiplying everything by 2. For the denominator, now I want to get positive 2y to become negative 14. So how do I multiply the bottom? By what? By negative 7. So the bottom, I'm going to place parentheses and I'm going to multiply it by negative 7. Okay. I'm going to go ahead and multiply this out. I'm going to get the following. So basically the top, everything gets multiplied by 2. So 2 times 3 is 6. That's 6x. 2 and 7 makes 14y. And 15 and 2 makes 30. That's the top. The bottom, I get the following. Negative 7 and 5 makes negative 35. Negative 7 and 2 makes negative 14. Negative 7 and negative 8 make positive 28. Okay. All right. So now our goal is to solve this. Okay. the goal is to solve this. So let's start by solving the x's. Let's combine like terms here. If I have negative 35 and I add 6 to that, or if you want to think about it the other way, 6 minus 35, what do we get left over? 6 minus 35 or negative 35 plus 6, either way. Think about what we get left over. What was that? Negative 29. So this right here is equal to negative 29x. Okay. What about 14 minus 14? What do I get there? 0. So like these cancel out. That's what we want. We don't want to have different variables. Now we just want x's alone. So the y's are gone. So we get negative 29 equals 58. And I know it doesn't seem like it, but negative 29 does go into 58. If you double 29, you get 58. So in this case, when we divide both sides by negative 29, you'll find that x is equal to negative 2. Yep. So let me write some more steps here. So after we find the common multiple, we combine. And then you can plug back into other equation. What I mean is, now that we know x is equal to negative 2, you can take this value of negative 2 and plug it back in to any equation. So for example, we had 3x plus 7y equals 15, right? That was the beginning one. I'm going to take this value of x equals negative 2, I'm going to plug it back into x for that. So that'll be 3 times negative 2 plus 7y equals 15. Negative 6 plus 7y equals 15. Plus 6 plus 6. Seven y equals 21. So y equals 3. Means you have a solution at negative 2 and 3. All right, I'm going to give you one more example that you're going to solve with your team. And then that's going to be it for class. Got it? We're all doing good so far? Yeah. Okay. Here is your last example of the day. Go ahead and take the next 6 minutes to solve this. Okay. Should be pretty easy. Give it a try. Turn the AC on. Give me one second.